A senior engineer can spend 10 years building production systems and still fail a 45-minute system design interview. In this video, I will show you 6 ways experienced engineers hide their own depth and a 7-step structure for exposing it. Here is what that often looks like. The prompt is, design a platform that pays creators. The candidate draws an API gateway, Kafka, Redis, several services, and a database. The diagram looks scalable, but the interviewer still does not know whether a retried payout can send money twice. That is the gap. The interview is testing whether you can make your judgment, mechanisms, and risk control visible on demand. The first failure is beginning with architecture before controlling the ambiguity. For a creator payout platform, what are the core user actions? Can a creator request a payout and check its status? Are scheduled payouts included? Which payment rails matter? Then come the non-functional requirements. What must always be correct? What availability and latency are expected? In this system, the hidden insight may be that correctness and auditability matter more than extreme throughput. Senior candidates should be able to turn adjectives into rough numbers. How many payouts per day? What is the peak request rate? How quickly does the ledger grow? You do not need perfect arithmetic, you need quantitative grounding. Numbers should change the design. If they do not affect any decision, the estimate was just decoration. You need to decide whether you are facing a throughput problem, a storage problem, or primarily a correctness problem. Suppose you add a queue between the payout service and the external payment rail. Which delivery guarantee are you assuming? What makes the consumer idempotent? What happens to a poison message? How do you retry? A component name tells the interviewer what box you recognize. A mechanism explains what guarantee the box provides and how the system recovers when that guarantee is insufficient. That difference is what defines technical depth. For the payout system, you might name a wallet, ledger entry, and external transfer. Now state the invariants. 1 payout per idempotency key. Balanced ledger entries. Corrections happen through reversals, not silent edits. Senior level data modeling is not a list of nouns. It is ownership, keys, state transitions, and the rules the system must never violate. Explain which guarantees happen in one transaction and which become consistent later. Pause here and answer this. Your payment rail request times out. You do not know whether the provider moved the money. What happens during the next 10 seconds? What happens during the next 3 days? If your answer is only retry it, you may pay twice. If your market failed, you may lose track of money that moved. The mature answer treats the timeout as an unknown outcome. Preserve the idempotency key and reconcile against final records. Production systems fail at boundaries. The process dies before writing the payout, but before publishing the event. The webhook arrives out of order. A transfer reports success and returns days later. A mature design discusses retries, reconciliation, and rollback. You do not need to explore every failure in equal depth. Use the requirements to choose the failures that threaten the most important guarantees. Focus your recovery design on the risks that actually matter to the business. A candidate may know the material, but present it as disconnected fragments. They jump from caching to schema details without giving the interviewer a stable map. Pristone Academy uses a 7-step framework in 3 beats. Align functional and non-functional requirements. Design the API contract, data model, and architecture. Defend. Deep dive into trade-offs and summarize the risks. The sequence makes your decisions easy to follow. In production, you inherit context and can revise designs over weeks. In an interview, you start with a blank canvas and an observer who cannot give you credit for reasoning they never hear. Preparation is training to make that knowledge visible. If your feedback says lacked depth or too high level, Pristone Academy's system design diagnostic is built to locate the failure mode. We look at everything from quantitative reasoning to operational maturity. System design depth is not how many boxes you draw. It is how clearly you can defend what each decision protects and what happens when it fails. Visit pristoneacademy.com to build your plan.